Let's explore the strace command, a powerful tool for tracing system calls and signals in Linux. It's essential for debugging and understanding how programs interact with the operating system kernel. So what exactly is strace? It's a diagnostic and debugging utility available in Linux that allows you to monitor and record system calls made by a process. System calls are how a program requests services from the operating system's kernel, such as reading or writing files, managing memory, or interacting with hardware. By using strace, you can gain insights into how a program interacts with the kernel, making it invaluable for troubleshooting and understanding application behavior. Here's the basic syntax of strace. Strace followed by options, and then the command you want to trace, along with any arguments. For example, to trace the ls command, you would type strace ls. The output shows the sequence of system calls made by the ls command, such as execf, which is used to execute a new program, and brk, which is used to adjust the size of the data segment. Now let's look at the basic usage of strace. The general syntax is strace followed by options, and then the command you want to trace along with its arguments. To trace a simple command like lsl, you would type strace lsl. This will display the system calls made by the ls command with the l option. Another useful feature is the ability to attach strace to a running process using its process identification number, or PID. The command for this is strace p followed by the PID. For example, strace p1234 would attach to the process with PID 1234 and trace its system calls. When you run strace ls, it shows all the system calls made by the ls command from start to finish, including file operations, memory management, and process control. Using strace ppid attaches to an already running process, allowing you to debug applications that are already executing without restarting them. Let's explore some common options used with strace. The F option tells strace to follow child processes as they are created by the trace process. To use it, you would type strace F followed by the command. For example, strace F /my_program. Next, the O option allows you to write the trace output to a file instead of displaying it on the screen. You can use it by typing strace O followed by the file name and then the command. For example, strace O output.xls. The P option, as we discussed earlier, attaches strace to a running process using its PID. The syntax is strace p followed by the PID. For example, strace p1234. The C option counts the time, calls, and errors for each system call, and reports a summary when the trace command finishes. To use it, you would type strace C followed by the command. For example, strace lsl. The option allows you to filter specific system calls to trace or exclude from tracing. The syntax is strace followed by the filter expression, and then the command. For example, strace open read write ls. Finally, the T option prefixes each line of the trace output with the time of day. To use it, you would type strace T followed by the command. For example, strace ls. One of the most powerful features of strace is its ability to filter system calls using the option. This allows you to focus on specific types of system calls, making the output more manageable. The option allows you to filter which system calls to trace, making output more manageable and focused. You can trace specific calls using trace equals open, read, write. To exclude specific calls, use trace equals open, close. You can also trace file operations using trace equals file, network operations with trace equals network, and inter-process communication, or IPC, operations using trace equals IPC. For example, to trace only file open operations, you would type strace etrace equals open ls. To trace all file-related system calls, you would use strace etrace equals file ls. To trace everything except read calls, you would type strace etrace equals read ls. And to trace multiple categories, you can combine them like this: strace etrace equals file, process, network getexample.com. Strace provides several options to format the output to suit your needs. Here's a rundown of some common formatting options. The T option prefixes each line with the time of day. Using TT prefixes the time including microseconds. The T option shows the time spent in each system call. The R option shows a relative timestamp from the start of the trace. The SN option limits the string output to n characters, which is useful for preventing very long strings from cluttering the output. Finally, the V option enables verbose mode, providing unabbreviated output for system call arguments. For example, running strace TLS will prefix each line with a timestamp, making it easier to see when each system call occurred. Using strace TLS will show the time spent in each system call, helping you identify performance bottlenecks. And strace s32cat/etc/password will limit the string length to 32 characters, which can be helpful when dealing with long file paths or content. Many applications create child processes to perform tasks. By default, strace only traces the parent process, but you can use the F option to follow child processes as well. The F option allows strace to follow child processes and trace their system calls too. It traces all child processes created with fork, and clone. Each process's output is prefixed with its PID, making it easy to distinguish between them. This is essential for debugging complex applications that rely on multiple processes. The F option can also be combined with O to save the output to a file. For example, to trace a command and all its child processes, you would use strace f-c ls-grep file. The sample output shows the PID of each process followed by the system call being made. For instance, 12,345 execf indicates that process ID 12345 is executing a new program, and 12,346 execf shows that process ID 12346 is also executing a program. Strace can be used for performance analysis by identifying which system calls are taking the most time. The C option provides a summary of all system calls, showing which ones are most frequent and time-consuming. The C option identifies bottlenecks in application performance. It shows the total time spent in each system call, counts the number of calls and errors, and helps pinpoint inefficient input-output or resource usage. The C option can be combined with F to profile child processes as well. For example, to generate a performance summary for the less-l command, you would use strace cls-l. The sample output shows a table with columns for percentage of time, seconds, microseconds per call, number of calls, errors, and the system call name. This allows you to quickly identify which system calls are consuming the most resources. In the sample output, the open system call is highlighted, indicating that it's taking a significant amount of time. Strace is invaluable for debugging applications by revealing how they interact with the system. Here are some common debugging scenarios. It can be used for finding missing files or libraries, identifying permission issues, detecting network connection problems, troubleshooting hanging applications, and analyzing application crashes. For example, if an application is failing to start, you can use strace to see if it's trying to open a file that doesn't exist. The output open /etc/config onf o_redonly equals -1 annuant indicates that the file /etc/config onf is missing. Similarly, if an application is failing to write to a log file, strace can reveal permission problems. The output open /var/log/applog o_ronly equals -1 each shows that the application doesn't have the necessary permissions to write to the log file. For network-related issues, you can filter the output to only show network system calls using strace etrace equals network /connect_app. To get the most out of strace, it's important to follow some best practices and be aware of its limitations. Here are some best practices. Always filter system calls with it to reduce output volume. Use O file name to save output for later analysis. Add timestamps with the for timing correlation. Combine with grep to find specific errors. And use C for initial performance analysis. Here are some cautions and limitations to keep in mind. Strace can introduce significant performance overhead when tracing. It may alter the behavior of time-sensitive applications. The output can be overwhelming without filtering. And it requires root privileges for tracing other users' processes. If you're looking for further resources, you can refer to the Strace man page by typing manstrace in the terminal. Related tools include ultrace, perf, and strace. For advanced usage, you can combine options like this: strace CFE trace equals network, open, close, read, write. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.